Welcome students. In this module, we are going to discuss about problems in raylighs method. We know in model analysis, dimensional analysis, we having two methods. First one is raylighs method, then second one is Buckingham's pi theorem. Out of this raylighs method is limited to up to three variables, up to two variables, but Buckingham pi theorem can be applied for more than three variables also. Okay, now let's discuss some problems in raylighs method. In problem 1, time period of pendulum depends on length of the pendulum and acceleration due to gravity g. Then derive expression for time period. Here the given time period is a function of length of the pendulum and acceleration due to gravity. Now what we have to do is we have to write in raylighs method. I am writing this as for removing this functional time, inserting constant k. Okay, then I am taking first variable power small a and second variable power small b. Okay, then we know that we already know for time period dimension is capital T, that means time, seconds. For length we know dimension is L. For g, acceleration due to gravity, we know dimension acceleration due to gravity, its unit is meter per second square, that means L by t square, which is nothing but L t power minus 2. Now I am substituting dimensions in this equation 1. Okay, I am substituting dimensions in equation 1. If I substitute, t is equal to k into L power a L t power minus 2 whole power b. Now I am just simplifying this by making L terms in one single. I am writing this as L power b t power minus 2b. I am writing this again as L power a plus b t power minus 2b. Here t power 1 only. Remaining things are here m power 0, L power 0. If I equate both side L's power, I will get 0 is equal to a plus b. Like that, if there is no m term here, so we no need to bother about m. For t power 1, here t power minus 2b. So 1 is equal to minus 2b. By using this, I can say calculate b equal to minus 1 by 2. If I substitute this b at here, I will get a is equal to 1 by 2. If I resubstitute this in first equation, k into L power a g power b, if I substitute a and b values here, then I will get t is equal to k into L power half g power minus half. I am writing this as root of L by g. So this is the final equation, my expression for time period of the pendulum. Like this only, we are going to solve two more problems in raylighs method. In problem 2, they are asking find expression for drag force on smooth sphere of diameter capital D and moves with uniform velocity capital V in a fluid density of rho and dynamic viscosity of mu. They are asking for drag force. I am taking drag force as capital F is a function of diameter, velocity, density, dynamic viscosity. Now I am writing this as some constant times d power a, v power b, rho power c, mu power d. Now I have to write dimensions for F. I know force. Force is nothing but mass times acceleration. For mass, dimension is m. Acceleration, last problem only we saw as L t power minus 2. So for force, dimension is mlt power minus 2. Like that, diameter, its unit is meter. Okay, so its unit is meter, so it is comes under length, and that means length dimension. For velocity, its unit is meter per second. For meter, L, for second, pi second. So I am taking this LT per minus 1. For density, we know kg per meter cube. Its unit is kg per meter cube. For kg, I am putting m. For meter cube, I am placing L per minus 3. Okay. For mu, that is one of the important parameter. Mu, for mu I am writing here. For mu, its unit is Newton second per meter square. For Newton, we derive dimension here. So m l t power minus 2. For second, dimension is t divided by, for m square, meter square, dimension is l square. If I substitute and cancel, I will get m l power minus 1 t power minus 1. Okay. Now I am substituting dimensions in both sides. M l power t power minus 2 is equal to some constant time l power a, l t power minus 1 whole power b, because for velocity l t power minus 1. For density, m l power minus 3 whole power c. Like that, for viscosity, m l power minus 1 t power minus 1 d. In this case, then I am expanding this. Okay, m l power minus 2 is equal to k into l power a, l power b, t power minus b, m power c, l power minus 3c, m power d, l power minus t, t power minus t. I am rewriting m terms alone. Here m terms, so c plus d. Like this, l term a plus b minus 3c minus d. Like that, for t term, t power minus b, t power minus, so minus b minus t. Here m l t power minus 2. Here we are considering there is 1 1. So I am equating m's power 1 equal to c plus d. Then equating l term, l's power a plus b minus 3c minus t. Equating t's term minus 2 is equal to minus b minus d. Okay, now we have only 3 equations. 1, 2, 3. But we having 4 constants. So what I am going to do now is I am substituting a comma b comma c, both all 3 terms in terms of d. For example, I am writing c equal to 1 minus t. Here I am writing b is equal to, I am taking b into this side, so 2 will be 2 minus t. If I know a and c, if I substitute here in the second equation, I will get 1 is equal to a. Instead of b, I am substituting in terms of d, plus 2 minus d minus 3 times 1 minus t and c value, then minus t. If I solve, I will get a is equal to 2 minus t. So I am writing a, b, c in terms of d, and I am going to resubstitute in first equation. Okay, we know first equation. What is first equation? I am having these 3 values. First equation is f is equal to k into d power a, v power b, rho power c, mu power d. If I substitute a comma b comma c values here, I will get d power 2 minus t, v power 2 minus t, c power, density power 1 minus t, then mu power d. Okay, in this again I am splitting constant terms and d power terms. So k into d square, d power minus 2d, d power minus t, v square, p power minus t, rho power minus t, mu power d. So k into, I am writing remaining things, okay, remaining constant things here, k into rho d square, v square. Then I am taking remaining power d terms, that is nothing but d power minus t, v power minus t, rho power minus t, mu power d. So I am writing this as k into rho d square v square into mu divided by d power d v power d rho power d. Okay, if I take d outside, I'll get this term as mu by rho v d whole power d. This term is nothing but Reynolds number. So it's a function of Reynolds number. So f is equal to k into rho d square v square into function of Reynolds number. So it's a basic one of the problem which we can solve using Raylighs method. But one of the problem here is here four constants were available. Four constants were available: small a, small b, small c, small d. But we had only three equations. This is one of the limitation in this Raylighs method. Now let's see one more problem in Raylighs method. In third problem, we are going to discuss about find expression for power capital P developed by pump depends on head, discharge and unit weight. In this case, what I am going to do is power is a function of head, discharge, unit weight. Okay. So for remaining functionality, I am adding constant. I am writing as h power a, q power b, unit weight power c. Now I am going to derive the dimensions for power. I know what is power. Power's unit is power is nothing but rate of doing work. Work done by time. Work by time. Okay. So what is meant by work? Work done by time. We know work is nothing but force times distance. Force into displacement by time. I am writing force dimension as mlt per minus 2, which we used in last two problems also. For distance, dimension is length. For time, dimension is t. If I substitute and solve, I'll get power's dimension will become ml square t power minus 3. Like that, discharge's unit is meter cube per second. We know for meter cube L cube by second for t. So I am writing it as L cube t power minus 1. For unit weight, I know unit weight is nothing but weight by volume. Okay, for weight unit is Newton, for volume unit is meter cube. Okay, for Newton we know powers forces unit is Newton. So for Newton I am writing as mlt power minus 2 by volume L cube. If I substitute, I will get for unit weight I will get m L power minus 2 t power minus 2. Okay, now I got all terms dimensions. So I'm going to substitute in this equation. I'm writing P's dimension as m L square t power minus 3 k into h power. We know sorry, for h we know h is nothing but head. It's like dimension is L, so its unit is meter. For q, L cube t power minus 1 power b. For c, unit weight m L power minus 2 t power minus 2 power c. Okay, if I write writing m terms and if I consolidate m terms and a terms, okay, if I now equate both side powers, I will get c is equal to 1. Okay, I will get I am erasing this term. Okay, if I equate, I will get 1 is equal to c from power m, from power L I will get 2 equal to a plus 3b minus 2c. For t power minus 3 equal to minus b minus 2c. So I know c value. If I substitute c value here, I will get b value is equal to 1. If I substitute b value and c value at this equation, I will get a value will be is equal to 1. Okay, so I will get a equal to 1, b equal to 1, c equal to 1. If I substitute this value in h power a, q power b, unit to 8 power c, if I substitute everything, then I will get p is equal to k into h power 1, q power 1, unit power 1. So this is the required equation or expression for power. We can check by using experiments, we can calculate these constants. Okay, these are the three problems we are discussed in raylighs method. Now I am giving one homework problem which has five dimensions. For that you have to convert a comma b comma c in terms of d comma e. Then you have to solve. I will just give idea about that problem. Remaining things you can solve by your own. Okay, now I will give a problem and I will give some hints and final derivation. Okay, here find the expression for force R. They are taking force as R, but you can take it as F also. I am taking F. F is a function of remaining things L comma velocity comma viscosity comma density comma K. Then I can write it as some constant. So here we are using K, so I am taking this constant as capital A for avoid confusion. L power small a, e power small b, mu power c, rho power d, k power e. We know for F we know dimensions, for length we know dimension as L, for velocity we know dimension as L t power minus 1, for m L t power minus 2, for L dimension is L, for mu m L power minus 1 t power minus 1, for density m L power minus 3, for bulk modulus it's nothing but unit of stress m L power minus 1 t power minus 2. If I substitute and I will solve, I will get if I equate m's power and L's power and t's power, then I will get three equation. One is a power of m. If power m equation will be like this, L equation and t equation. M equation will be 1 equal to c plus t minus e. L equation will be 1 equal to a plus b minus c minus 3d minus e. T's equation equal to minus 2 equal to minus b minus c minus 2e. Here we having three equations, but we having 5 constants. So what I have to do is we have to convert two things into another thing. I mean we have to convert a, b, c in terms of de or any 3 in terms of 2. For selecting that, we can take any unknowns. Here we are converting a comma for simplification. We are converting a comma b comma okay d okay in terms of c comma e. For example, I am taking from this equation I am writing d is equal to 1 minus c plus c. Okay, then from like that, if I write now I wrote t in terms of c comma e. If I substitute this in this equation and if I solve, I will get a also in terms of that a equal to minus 2 minus c. Like that, b will be is equal to 2 minus c minus 2e. You will if you solve, you will get this equations. If you substitute a b c, I mean a b c, a b d and c and es, c and e itself, and if you solve and consolidate c's equation, I mean c's terms and constant terms and e's power terms, you will get a final equation as drag force is equal to that function of rho L square v square. It's a function of two things. One is mu by rho v L power c Another is a function of bulk modulus divided by rho v square power e. Okay, with this I am completing this module. I hope you understand some problems in Rayleigh method. In next module we will discuss about Buckingham Pi theorem. Thank you.